Hello and welcome to the Chemistry Made Simple podcast. I'm your host, Matthew Macario, and this is the podcast where you get chemistry confident and we take you from point A to grade A. Hello and welcome to this week's episode. I hope you're well. Today we're going to talk about infrared spectroscopy. We're going to talk about how the infrared spectrometer works and how the spectroscopy works. We're going to talk about the spectrum that's obtained from analysing a sample. We'll talk about how you will use the infrared spectrum and also mention about the fingerprint region, why that's really useful to analytical chemists as well. So firstly, let's talk about what is infrared spectroscopy. How does it work? The principle is that each bond within the molecule of a particular compound will vibrate at a particular frequency. The principle is based on the fact that each bond in a molecule behaves a little bit like a spring, and each bond will vibrate, and the frequency of that vibration depends on a number of things, primarily the mass of the two atoms in the bond, but there's also influences from the surrounding chemical environment within the molecule. And that, of course, makes each bond type really quite distinctive. It will have its own frequency of vibration. We can use an instrument to pass infrared radiation through a sample, and radiation that corresponds to the vibration frequencies of the bonds within the molecule, within the sample, will be absorbed, and we can use the instrument to measure how much is absorbed and, most importantly, what frequency of radiation is being absorbed. So how do we do this? We use an infrared spectrometer, and that spectrometer passes a beam of infrared radiation that contains a range of frequencies. It passes that beam through a sample, and the energy that's not absorbed reaches the detector and is measured. A spectrum is obtained because the signal being detected is processed, and a graphical representation of transmittance that passes through the sample at a particular frequency. So we end up with a spectrum that shows peaks where the transmittance is low at particular frequencies or frequency ranges. Therefore, chemists can identify the types of bonds present within the molecule, within the sample. One thing worth noting is instead of frequency, the spectrum is usually showing wave number. Wave number is proportional to frequency, and the unit of wave number is usually per centimetre. In other words, how many waves of that radiation per centimetre, and that, as I say, is proportional to the frequency of that radiation. So what can we do with that spectrum? How can we use it? Particular bond types give quite distinct peaks in the spectrum. So, for example, there's a very distinct peak at approximately 1700 wave numbers. That very sharp peak is an indicator that there is a carbonyl group, that's a carbon double bonded to an oxygen, present in the molecule. That bond type has a very strong absorbance of energy and therefore a low transmittance, giving a sharp peak at around 1700 wave numbers. There are also distinct, quite broad peaks associated with bonds between oxygen and hydrogen, and that can occur between 2500 and about 3500 wave numbers as well. And depending on exactly which part of that area the peak is and how broad that peak is will indicate whether that OH group is due to a carboxylic acid or is due to an alcohol or phenol. There are other distinct peaks as well that can help us to identify bond types and therefore help us to identify which group of compounds the sample might belong to. Are you expected to remember all those? Well, no, you don't need to. Certainly if you're studying chemistry at A-level in the UK, you'll be given a data sheet if you're doing an exam. You'd also find a data sheet in your textbooks as well. And that data sheet will include a section on infrared, and within there you'll find a number of known peaks and bond types and a description to help you identify the bond types and even compound types that a particular peak would indicate. Of course, if you practice questions like this and using the data sheets prior to going into the exam, then you'll have a feel for how to use that during the exam. Okay, so that information tells us a bit of information about the compound type that we might have, whether we've got a carboxylic acid, an alcohol, an amine, something like that. But it doesn't identify the exact compound. And infrared can be used to identify exact compounds. It's a widespread tool for quality control to identify exact compounds and identify whether there is contaminants present as well. And that's done because there is something called the fingerprint region. The fingerprint region is a region from around about 1500 wave numbers and below, which tends to have a very complex set of peaks. It's not a set of peaks that you're going to find on the datasheet to help you identify a specific compound, but it is a set of peaks that you can compare as a fingerprint against a known sample of the pure substance you're expecting, or use the software to compare to a digital library containing spectra to help identify the exact compound that the sample is. Where the sample is intended to be a product from a reaction, this can be used to identify whether there are additional peaks present, which might indicate that actually there's an impurity as well. So it's really good in quality control for that reason. Again, if you're studying A-level, you're certainly not going to be expected to identify specific compounds just from the infrared spectrum, but you are expected to understand what the fingerprint region is and what it might be used for, how it might be used. Okay, let's have a brief summary of what we've talked about today. We talked about infrared spectroscopy being an analytical chemistry tool that we would use with organic compounds. We said that the principle is based on the fact that different bonds have different frequencies of vibration, and that's down to the atoms that are attached by the bond and also the chemical environment around them in that molecule. We said that we can pass a beam of infrared energy through a sample and measure the amount of energy that passes through the sample and gets to the detector and plot that against the wave number of the energy. And that gives us an indication of what bonds might be present. We get a spectrum and we can compare the peaks we find in our spectrum with a datasheet that indicates the bond types that we might be looking for and the wave numbers that those would be found in. We also mentioned that we can use the fingerprint region below 1500 wave numbers, and that helps us to identify exact compounds or identify the presence of impurities if this is being used for quality control. Okay, I hope you found what we've talked about today useful. If you do have any questions about this topic, the best place to contact me and ask those questions is on our Patreon community at patreon.com/chemistry made simple. And there's a link in the episode description to take you there if you want. And I really do like to hear from you, so please feel free. I'd love to hear from you. Thank you for listening to this episode. I hope you found it useful, and if you have had value from it, do consider visiting our Patreon community at patreon.com/chemistry made simple, where you'll be able to ask deeper questions about this topic and get more support for your studies too. So I look forward to speaking to you again in the next episode, and until then, do look after yourself and goodbye.